12.
And action.
10. Uh-oh. And action. Hey, Blue On started a live video.
Sweet.
And there we are.
Cool.
Woo. Hey guys, welcome back to Buckle Up. Whoop whoop. Can I get a whoop whoop?
Can we get a whoop
You
whoop?
get a whoop whoop when you get in front of the camera.
Okay, awesome.
Oh, no, I can't. I'm sorry, I can't. I gotta shut that off. That was bad.
What was bad?
Well, my ears listen to my phone.
Oh.
Oh, okay. So today's episode is on low voltage wiring. So if you have questions about that, ask them away in the chat, and these two fellows will answer them for you.
Mic check.
Or at least we'll make up a good answer.
Mike is back,
Mike's
everyone.
here.
Mike is back.
No, it's Mike's front.
Before we get started, our next episode is on September 2nd at 4 p.m. Pacific, so be sure to tune in for that. Mark it on your calendar. We have some very, very exciting news to announce.
What is it?
Could
Something
that
tell us about
everyone
it?
has been waiting for so long now.
I know two guys that have been waiting for it to happen for so long now.
The Blue On forum is now live in the
that's
Blue
it.
On app. Super cool. So everyone, make sure you update your app. Go to the App Store. You'll see a little update icon. Hit that. Update your app, and then you can start communicating with other techs in
As
the
well
Blue
as
On
our
forum.
techs.
Yeah, the 60,000 plus that are in there now. You can communicate with them, ask questions. It's a really, really cool thing. Brian, do you wanna talk a little bit about how that works real quick?
Well, I do, actually, before we get into low voltage wiring. We've been telling you, we've been promising you, the forum is up. Not only is the forum up, but we did the major upgrade to the app. So you'll see where you're used to seeing the 3 icons at the bottom, you're now going to see 4 icons at the bottom. Tech support is still there, but now the tech support has changed just a little bit how you do it. So you go into tech support the normal way, you hit the button in the bottom right hand corner. It says tech support, but now you've got options of wiring diagrams, manuals, under 20 ton, over 20 ton, chillers. So when you go into that section, it's gonna ask you if you are really prepared to get on the line with Mike and I, or one of the other guys. If you are working on a 5-ton package unit, then it's going to make sure that you've got your meter, your gauges, jumper wires, things that are going to be required for communicating with us because we're not on the job with you. And the other feature that has been added is the Superheat subcool calculators for all the common refrigerants now, not just the 2 that we care about.
But even better, the one that has been missing for so long is the Target Superheat calculator.
Yeah.
Because so many guys, they turn around and say, yeah, 12 degrees superheat. Well, on a piston or passive metering device, that superheat is going to change anywhere from about 5 all the way up to 45 or 50 degrees superheat. And so this gives you the way to calculate it and everything else right on the app. You're not trying to read that stupid thing on the side of the door that the middle section you need is gone. So,
Got a little hot.
Guys, it took a while to get there, but we've got the stuff there. We're trying to add more and more things to make your lives easier.
Yep.
It's really, really cool. And when it comes to the forum, we're in this together. And so we need to help each other. So go to the forum, see what's out there, and maybe you've got a solution to one of the issues that nobody has put in there.
Yeah.
And that's really, really important. But most important, this needs to be a safe space where it's not about attacking people or putting people down, because it's said that there are no stupid questions, but God only knows I asked a bunch of them when I was young. So,
Well, and you got to remember, we've all been there. We've
Yeah.
all been in the place where we didn't understand where W-2 went, even though W-2 doesn't exist. Sorry, that's an inside joke from my family. So, be kind, treat others like you want to be treated, and remember back when you didn't know anything about this trade. These guys getting out of school, they're in our trade. It's a great trade to be in, and ride the wave. Help them learn, and it's just like you guys calling us on tech support. We don't hang up on you. We walk you through whatever the problem is, and I'm pretty much thinking we do it with a smile on our face, because we remember, and it just puts I know for me personally, it's the mindset. I enjoy the teaching aspect of the trade, and you guys remind me of the first time that I saw, I did, when I first got in, I was light commercial and residential, and the first time I opened up a train Saha, all black wires, all Essex brown relays, and it's a bank of them. I mean, the bank of relays was bigger than the van I pulled up in. And I remember sweating that job out. But you just got to remember the basics and start at the same point all the time.
well, we got any other thing, how do you dive into one of those systems? One bite at a time.
Yeah,
It's
right.
just a bunch of little pieces,
Just like eating an elephant.
So don't get intimidated by it. There's just a lot more there,
I
and
think-
typically the drawings are a lot better.
I think we're ready to jump into some of the
So
basics.
that is a nice lead in with the whole schematic or the Saha story, is to lead in today's topic of low voltage wiring, and in that is low voltage troubleshooting. So I've taken the liberty, because I had that kind of time a minute ago, to
You get time?
no, I don't, but I had time a minute ago. So Mikey's already given me crap about my little drawing. So you have a transformer that's primary voltage, and the reason I listed it as primary voltage is depends on whether you got a 115 volt transformer or a 230 volt transformer as your primary power. So that's primary. Then you have your 24 volt section. 24 volts. If you look at the thermostat, the 24 volts from the thermostat or from the transformer goes to R. Now break it down to make it easy for yourself. G is your fan, Y is your cooling, and W is your heat. You notice there's no switch for C on the thermostat. If it calls for C, which most of the digital programmable thermostats do, C comes back to the transformer. So you have a series of switches. When your thermostat calls for cooling, then the Y will close and the G will close. G brings on the fan, Y should bring on the condensing unit. So I broke that down a little bit further. I'm going to give this to Michael.
Okay, so let me ask you this question.
Yes, go ahead, ask me a question.
How do you know which one of the wires is the common on the transformer?
Well, it's going to be the one not plus.
Ah!
And a lot of manufacturers, I will do this because I brought my crayons. A lot of the manufacturers will actually take the common and chassis ground it.
Yes. Because there is no correct. Once you ground this one and connect it to common, that's the common side. So
But a lot of manufacturers don't actually ground their transformers on the low voltage side. A lot of them don't.
that's just because they couldn't afford the ground wire.
I understand it's small and they got cheaped out. So I'm going to give you that
Okay.
because I showed this because everybody's used to seeing this on the sub base and they kind of understand what the switches are doing, but that's really not the troubleshooting part. So I'm going to give you this. I know you wanted to work on something as well.
Well, I kind of wanted to work on the thing, and we're starting to run into an issue that we had a little while back with doing high voltage and stuff like that, or higher voltage, and people want to reference to ground. And so you can reference to ground for certain things, but I've seen in one of the calls I had past few days, a young man was reading from one side of the contactor coil to ground, and he says, I got 24 volts there, and then I go to the other side of the contactor coil, and I got 24 volts to ground. So I got 24 volts going through the contactor coil.
Right.
Well, no, you really don't. You have 24 volts of potential there,
But you don't have a complete
but
circuit.
you're not completing the circuit.
And that's what I've got on the bigger board. So
Brian's been busy out
I
here.
had a couple of minutes.
All right.
And I even brought a contactor coil out.
Did you?
For you.
Sweet. All right.
It's not that we talk or anything.
No.
So, same principle. If you see your primary voltage transformer 24 volts, if Mikey, to help Mikey out, I'll put the little ground in there.
I need lots of help.
Yeah, well, it's all right. So there's your chassis ground. So now, a lot of guys when they're doing this, they talk to us and they're going, I'm reading 24 volts between R and Y, and my cooling's not coming on. Well, here's why, or at least one reason why. If you read from R to Y and the thermostat is not closed, then you're going through the contactor coil back to common. So you would read 24 volts. And Mikey's going to draw the pressure switches, or he's going to try to.
Try to. And for those of you who don't know the difference between these two, this one here is a switch that will open on pressure rise, and this one here is a switch that will open on pressure fall. So one of the things you can do, and I've rented this a couple times this week, they've got 24 volts to the contactor coil. If you read the contactor coil from here to here, and you're going directly to the contactor coil, and you have 24 volts here, you got a bad contactor coil.
Yeah,
Plain and simple.
pretty much.
All right. But what happens a lot of times is here's these wires out here where it connects into the unit, and they want to go and read the wires here, and they say, but I got 24 volts going into the contactor coil.
Yep.
Where you really don't have 24 volts going into the contactor coil, you have 24 volts going into the condensing unit.
Yeah, you can have 24 here and still not have 24 at the contactor coil. That's these connections, because one of these switches could be open.
Right.
Or a lot of times they will put when you're looking in the condensing unit, you're going to see a connector here where they connect one wire coming off the pressure switch and one wire coming off the low pressure switch, one wire coming off the high pressure switch, and they have a connector, plastic connector, because we can get into that. We're going to get into that too, is the difference between ohms and continuity. Continuity makes sound, ohms is a reading.
Olds was also a really old guy.
And he's a really old guy. So when you're going from R to Y and you're reading 24 volts here, it's because you have this coil of wire, so you're getting the back feed. Common through the coil of wire coming back to Y because of that. So you can kind of see that. You're going to get a 24 volt reading, but this coil's not pulling in, because you don't really have 24 volts here until you close this switch. Once this thermostat closes, then you'll have 24 volts on this side, and this should return back to your common. So the reason we did this is if you're looking at the furnace air handler and you're looking at that board, take your readings from Y to C on that board, and that will tell you whether or not you actually have 24 volts going out to the condensing unit. And you do the same thing. You do G to C, and that will tell you. If you want to know if you've got your 24 volts, you go from R on the board to C on the board. And if you don't have a board at the furnace or air handler, then where the thermostat wires all connect. There's a bundle of wire, but you should have a board in today's technology.
One thing I also want to comment on too that I'm seeing more and more of that's driving me nuts. The one constant that we actually had in air conditioning for a given period of time is kind of going out the window. You know, as Brian did on the thermostat here, you know, red typically goes to the R terminal and Y typically goes to the yellow terminal.
Yep.
And you got your red, you got your yellow, your white, your blue or your orange, you know, all these different connections.
Yeah, we used to have a standard color code that we used in the trade. Electricity does not give a darn what the color of the wire is. It is our standard that we created as an industry,
Yeah.
and some engineers and inspectors.
Yeah. But
Someone asked, can you just go from Y to ground?
If it's chassis grounded, and you went from Y to ground or to chassis ground, if this was closed, yes, theoretically you should read 24 volts. But if it's not chassis grounded and you go from here to chassis ground, then no, it's not going to read.
you know, one of the things I like to do is I like to start at the transformer and just read across here to see that I've got my 24 volts. If I've got my 24 volts,
What happens if you don't have your 24 volts?
get a bigger transformer. No, just kidding.
That's where you go up, Mikey calls it the prim. That's where you go to your prim side, your primary side, and see if you've got primary voltage. And again, I didn't write it down. It's either 120 or 230, or if you get into the larger equipment, it could be 460 as your primary voltage side. So always be careful, know what you're working with. But if you don't have it at the transformer, check your primary, make sure that your primary has power, and then call Mike.
Couple more questions from Brianne. Brianne asks, where's the W2 wire?
We already discussed that. There is no W2 wire. No. In this example, we're not using W2. That's my inside joke coming back to bite me in the butt.
There you go. You'll learn.
Another question. What is ghost voltage or feedback?
Oh God, this can be a lot of fun.
That's not a basic low voltage question. That is
But I'll throw an answer into it.
well, we can. You're going to see ghost voltages. You're going to see back EMF. What's his other one?
Capacitive coupling, inductive coupling.
So, with today's equipment and this communicating, you're going to see more ghost voltage stuff if guys don't wire this stuff right. Again, I disagree with some of the manufacturers saying that you don't have to have shielded cable on comm wires, but
They're trying to do it more with data and calculations
and it's just
no.
it's like you put an antenna.
Well, let's hit a couple things real quickly since we
You opened that door.
Yeah. If I take a low voltage wire or a low voltage cable and I put it right next to some high voltage wires, you can get what's called inductive coupling and capacitive coupling, which means that the two wires are now acting like a primary and a secondary on the transformer. So you can induce a voltage from the high voltage wire into your low voltage wire. So whenever you're running low voltage wires, you want to try to keep them separate from the low voltage, or the high voltage separate from the low voltage. And if you have to cross the wires, do it at a 90 degree, because now the area that's up next to it is very small. So you're going to have a lot less of that problem. Another thing that you're going to run into is grounding and bonding is critical, because you want to try to get a lot of that noise going to ground. And if you're using a shielded cable, do not connect the shield on both ends.
No.
You just create
An antenna.
big ass antenna.
All right, you guys are all familiar with, I'm sure, 60 hertz AC sine wave. So,
I'm zooming in for this.
if you run your low voltage wiring close to your high voltage wiring, this is where you start to pick up your noise, which is why they tell you not to run them in the same conduit. They should be separated and separated by X amount of inches, but
Yeah, and now this is something we're gonna run into more and more as we get away from the standard, basically old style thermostat that were just switches,
Yeah.
and we get over now to more data carrying thermostats, because now the noise becomes interpreted as something to the control when it's not. You're reading noise.
So one of the things that we do, we recommend, the manufacturers recommend, and Mikey, can you throw me the eraser real quick? If you're going to hear us tell you to, or the manufacturer, if you read the instructions, tell you when you have a communication error, first try this: turn the power off. So you shut the power off to the air handler, you shut the power off to the condensing unit, wait for the thermostat to go blank, and then reestablish power. Some of them want the condensing unit on first and then the air handler or furnace on second. Some of them want it the other way around. Regardless, what happens when you do that, you shut the power off, is you've stopped this. When you reestablish the power, your high voltage comes back and your low voltage comes back. You still have that signal, but you've erased the ghost voltage.
You also reboot the controller a bit.
And reboot the controller.
I mean, think it. A lot of the air conditioning units nowadays, it's not the old, electromechanical devices, contactors, relays, and all that other kind of stuff.
Yeah.
It's a lot of data. And what happens when you boot up that device, it's loading a set of instructions in there, just like your computer does. And so if you get some garbage in there that just totally messes with the brain of this thing, just like your computer, you shut it down, you reboot it, you get a clean restart, and you can start moving forward.
Or another way to make all these folks that are using these smartphones, periodically, I know you shut them off and turn them back on. What you're doing is rebooting the computer in the phone. So that's the same thing you're doing when you shut the power off to the system and turn the power back on.
Someone asked, if I don't get 24 volts from Y to C, what should I be looking for?
Well, I think we got to depend on the conditions. Is the thermostat calling?
Well, yeah, that's going back to this drawing. If you go from Y to C and you don't get 24 volts, then you need to know whether or not you've got R to C. If you have 24 volts, you check your thermostat to see if you have voltage at the thermostat between R and C. Now look and see if the actual thermostat itself is closing. And the other thing you can do, that's why one of the features one of the tools that we want you to have when you call us for tech support is jumper wires. Is at the air handler, you can now hook up a jumper from R to C, which bypasses the thermostat completely, and you'll know whether or not it's if you jump from R to Y. Sorry, I think I said C.
You did.
If you jump from R to Y, now you know you have 24 volts potential going to the condensing unit.
Yeah, another thing that we've been doing a lot of apartment complexes, working with some contractors to do them. And one of the things we're running into are a lot of broken wires and bad thermostat subbases and things like this. In diagnostics, I kind of like to divide and conquer. So I'll go to the air handler and I'll turn around and jump the R to the wire going out to the condensing unit. And I'm not going to say yellow because unfortunately half the time it's a red and white wire or a black and a red wire. So you have two wires going out there.
Yep.
But if I turn around and jump from red to the non-common wire going out to the condensing unit, if the condensing unit comes on, that tells me that from that point out is good. Now I can turn around and I can jump from R to Y and see if it comes on. If it comes on,
Taking the
great.
thermostat
Taking the
off the
thermostat
wall,
off.
leaving the subbase.
Yep.
Jumper from R to Y at the subbase.
Yep.
See if the condensing unit comes on.
Yep.
we say that like it was a no-brainer, but it's not. There's other things that go into that as well. If you've got quite a hike because you can't hear the condensing unit, or you're not going to be able to go and feel the line and feel if the refrigerant's flowing in a short amount of time, we say jumper from R to Y, but if you're going to be running it for a while, make sure you turn the daggone fan on. That's R to G.
Yeah,
because
if you pull the sub base, it ain't gonna help. So
you need to make sure that the indoor fan is running if that compressor is going to be running for any length of time, because all of this is making sure we don't break a compressor. So
yeah. But one of the things, I've had the guys tell me, they say, well, if I go in and jump the sub base and the unit comes on, would you say that it's a bad thermostat? And I said, yeah, because if I can jump the wires at the sub base and everything works, then it's a bad thermostat.
Right. If you've taken the thermostat, room's 80 degrees, you've got the thermostat set at 72, and you've waited the most digital stats have a 5-minute time delay built into them. So if you've waited the 5 minutes, nothing is happening, the indoor fan comes on, and it still will not energize Y, whatever color Y is, if it still won't energize Y, then yeah, I would drop kick the thermostat and get another one. The reason that you take thermostat off the wall and jumper the thermostat wire is making sure that a rodent didn't chew the wires in the attic or in the basement or in the wall, because if you go from R to Y and nothing happens at the subbase, now you go to R to Y at the air handler or furnace. If it works at the furnace and brings the condensing unit on, and it doesn't work when you go to the thermostat, the wire is broken somewhere between the thermostat subbase and where it landed in the air handler. A standard practice that I did, and I got grief from it a lot of times. I got grief from it. But if I only needed 5 wires, I ran 18/8. That was pretty much my standard. Because I didn't want to re-pull that whole thing in case one wire broke.
I don't know how many calls I've gotten of late where they're putting in a 2-stage cooling unit and they're missing a wire.
Yeah.
And they're like, oh, now we got to come back in and pull that wire in, or they get a broken wire.
Yeah, it depends on whether the thermostat wires were done under construction or whether they were done as a remodel. As a remodel, you stand a pretty good chance of being able to pull new wire. As a new install, chances are that wire's tied someplace or stapled or
well, then
makes a big difference.
And the other thing, when somebody hangs a picture with a 3/8 lag bolt, go in there and hit
I've got some pretty heavy mirrors.
Guys, ready for some questions?
Sure.
A few of them in the chat. This is a good one. I think it's a good one. When troubleshooting low voltage wiring, would it be best to start at the thermostat on indoor let me just start over. When troubleshooting low voltage wiring, would it be best to start at the thermostat or indoor unit? Would I take into account if the system has a board or not? Best way to approach this?
I can help. Oh, gee.
Go ahead.
Pick me.
Mike.
I always go to the thermostat because the transformer, because I want to make sure I got voltage to make sure.
Yeah.
And then I can turn around and, like I say, I can jump it at the air handler, and if I jump R to G and the fan comes on, okay, I got some good stuff going on. If I jump R to the one side of the wire going out to the condensing unit and it comes on, okay, great.
Yeah.
So I can kind of work my way back. Now, when you get into heat pumps, it's a little bit different animal because on the defrost control board, a lot of times you'll have terminals for your low pressure switch, your high pressure switch, a defrost thermostat, and God knows what else they want to put in there. So you've got all those points that you can go look at. And a real simple way to kind of bypass that is look at Y in and Y out. If you jump across that and it comes on, okay, My issue is in the board, and it's not necessarily a bad board.
Right.
It just means that something is telling the board, hey, don't run the compressor because I got something going on.
Right.
I've seen a couple times where they've had this problem, and we get the phone call that they've replaced 2 or 3 boards, and I ask them if they've checked the temperature sensors, the thermistors, and they go, no. So they go and check the thermistor, and they got a shorted or an open thermistor, and that's what's telling the board not to let the compressor come on.
Right. So here's Brian's Troubleshooting 101.
Oh, geez, let me get a pencil.
Residential call. I always ask the customer when I walk in, where's the thermostat? So they'll take us to the thermostat. When you get to the thermostat, you get to turn the fan switch to on. You get to make sure that the machine is calling for cooling, provided this is a no cool call. So you go to the thermostat, you turn the fan switch from auto to on. Then you take and turn the thermostat down, knowing that it's going to be calling for cooling. The next question you have is, where's the air handler? Where's the furnace? Whatever. Now you go to that point. I didn't take any tools out. All I did was make sure the thermostat was turned down, turned on, and the fan was running. Now I went to the air handler, which is your control voltage source. And now I can check for my primary voltage. I can make sure the transformer's got 24 volts. So to answer that gentleman's question a little bit more specific, that was always my, once I saw that everything was working at the air handler, knowing that I turned the thermostat down, now I can check my voltages going to the thermostat. I can check my voltages coming back from the thermostat. I can jumper and see if the condensing unit will run. You can do a lot of troubleshooting right there at the furnace or air handler.
Pretty much you divided and conquered.
Yep.
Yep.
And it also, going back to earlier, which brought us into this whole control piece, is remember when you're taking the step from the residential light commercial and you're going to that train Saha, OMG, open up the doors, relays, wires, all the same color. Start at the same point, guys. Turn the thermostat on, turn the fan switch on, open up that big panel, ignore all the black wires, ignore all the gray relays, find the damn transformer, and see if you have primary voltage, see if you've got secondary voltage. Then go from there.
One of the things that Brian has left out is that on the bigger units, a lot of the wires typically go to terminal strips.
Yeah.
And they are very nicely numbered. So instead of having to go trace this wire in that bundle of black wires, I can go TB11 to TB111. I got my 120 volts. So I can go in and troubleshoot that way.
And reading the wiring diagram is super helpful.
Yeah. Having a wiring diagram to read is super helpful.
Hey, you can find that
On the Blue On app.
Nice. How do you bypass the circuit board to get a unit up and running while waiting on a circuit board?
That's kind of you got to be really, really careful with that, because number one, you need to determine whether or not you're jumping out an operating control or a safety control. And I don't have a problem jumping out safety controls, like people want to jump out high pressure switches. Great, jump out the high pressure switch, but make sure you've got your gauges on there to see what's going on. And you don't jump it out on a permanent basis.
Nope.
You jump it out just for a moment to see if that's your problem.
Yeah.
Some operating controls. I had one the other day where the guy was short of wire, and it was in a hospital. And what do you leave the fan on all the time, and turn around and stage your first stage and second stage cooling until you get the other wires pulled. So you can make some trade-offs, because in a hospital environment, it's not going to hurt you to run the fan continually. But you never want to jump out safeties other than for
Testing.
a real quick test.
Testing purposes only.
Yeah.
Do not walk away.
No.
Ever walk away. It is never okay to walk away from somebody's unit with a safety jumper. You can't even go to lunch.
Yeah.
It's like, oh, I'm just going to go out to my truck and get something and I'll be right back. No. no, you can't do that. Shut the machine off, go get what you want out of the truck, come back. You need to watch the machine the whole entire time you've got some kind of a safety jump. It's
Well, let's throw in a kind of a qualifier here. Guys, we're working with high voltage, we're working with high pressure, and these things can hurt you, okay? They can hurt you, and the pressures and things can change real quickly.
Yeah.
So when you start bypassing things, jumping things out, like I said, with the high pressure, I've got gauges on it. I wanna know where that high pressure is, because I don't want that thing coming on if I got 600 pounds of pressure in there. You know, I don't want that happening. So whenever you're doing things, be real careful, guys, because, you know, the stupid mistakes that we make, okay, we learn from them, we can laugh at them on down the road and everything else, but if you get hurt or worse, you know, it's not funny. I mean,
can't go backwards.
no, we joke and kid with each other when each other makes a mistake and things like that, but your safety is the most important things, guys. It really is.
Right. So now, if you're working, because the statement was a board, and machines have several boards. So if it's the indoor board and you're just trying to get the fan to come on, that's again relays and knowing what you're wiring. Condensing unit with the defrost board died, or the sensors aren't working, you need to get this thing back up and running, even if it's overnight. Always tie in your safeties, but you're going to rewire the whole machine. You're not going to have defrost if it's in the wintertime, you know, and you're trying to get these people heat. They're going to have to be that person that shuts the machine off or switches it into air conditioning. I mean, there's a lot of things that you have to do. But it's not just as easy as taking the thermostat wire and connecting it to the contactor, not on a defrost board, because you gotta jump out, make sure that the outdoor fan motor runs, that your pressure switches are all there. Obviously, if the board's bad, the temp sensors aren't gonna function, and that's not gonna do anything. That's not going to do anything in your bypass moves. But you may have to hook up relays to.
You can do it, but just be aware and kind of ask yourself, what is this board doing? And if I bypass this, what are the consequences that can occur? Because to turn around and bypass a board, you know, it's 95, 100 degrees outside, you know, and it's going to get down to 85 at night. To turn around and bypass a defrost control board, I could care less.
Right.
Because I don't have to worry about flooding back or tearing up the compressor or turning the condensing unit into a block of ice. I'm good with that. But if you need the defrost and everything else, it's not a good idea, because you went from now replacing a $500 board to replacing a $2,000 or $3,000 compressor, and that gets kind of hard to swallow sometimes. So just ask yourself that question. And if worse comes to worse, there's this really cool red button on the app. It takes you right straight to Brian. I help you, Brian. I help you.
I appreciate that, Mike. I appreciate that. Where do you want us to go, Jess?
Come on, Jess.
Looking for questions. Scanning the comments.
It's all good.
We answered some of these.
So on that, if the thermostat is now calling for cooling, that means this switch is closed. If we have a break on the common, again, you're going to read 24 volts between here and here, but you're not going to read 24 volts between here and here, because the common is broke. How does the common get broke? If it's a split system, again, it could be a rodent issue.
Mm-hmm.
It could be the people have got a gardener and somebody hit it with a weed whacker. It could be where they've connected the condensing unit wires to the thermostat wire. I've seen it time and time again where it's actually corroded in the wire nut. and gives you a bad connection. We were talking earlier about this connection down here. If this is all good, and I have 24 volts, and I don't get my 24 volts here, and you check your low pressure, and you check your high pressure, and you find out, because the guys will check those on continuity to where you hear the tone, that only means that there is some resistance here. Doesn't tell you what the resistance is. So I have guys go from this point to this point, and I want you to use ohms, not continuity. And if you have 50 ohms between here and here, that's no good. This should be more like 0.5 or 0.05 resistance. If you're at 0.5, the resistance is too high and you're not going to get good 24 volts to the contactor coil. Look at this connection, and if need be, I mean, they should be just stake-ons on there, but if you look at that connection and you take it apart and now re-ohm your switches, and you find this down at 0.5 and this is at 0.5, going from here to here should be 0.5. So eliminate that connection, strip the wire back, use a wire nut, tape it off real good, and get that back down to where it's a 0.5 and not a 0.5.
Yeah. Now, Brian just attacked this one with ohms or continuity. I like voltage. So if I turn around and go over here and hook my common leg of my multimeter,
That would be the black one,
and I go to here and I've got 24 volts.
the red one.
Now I can come down here, I've still got 24 volts. I come here, I still got 24 volts. I get up here, I got 24 volts. I go to the other side and now I've got 0. I just found where my open is at. So you can always use, there are gonna be things that you can't see unless the equipment's powered up.
Right.
And so if you're powering it down and trying to read continuity, it doesn't always work. So another way to do it, like I say, is just to put your alligator clamp on here from your common leg and put it on your appropriate voltage and just go boom, 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 boom. Oh, I lost it there. And it'll get you to where you're going without having to power down the unit. So it's just, there's some different ways of doing it. And
it's also about access.
it's about access, but it's also about different people have different methods of troubleshooting. And I'm not going to critique somebody else's, because if it works for them, that's great.
Yeah, and guys, you don't have to be at the switches. If you look at these, if you look at the boards, the defrost boards, the low pressure and high pressure switches come back to the terminals on the board.
Mm-hmm.
So, you know, like Mike is saying, I mean, I can already visualize where he's at working on a machine, the train Saha that I was talking to. Everything comes back into the control panel, you know, and you can do tests hot. You're not going to be able to reach in to a 5-ton condensing unit and take voltage readings at the actual pressure switches, because you know you can't get past the running condenser fan motor
Unless you're real fast.
That'd be super fast.
Super fast.
All right,
you know,
we'll start
go
to
ahead.
wrap it up. 45.
Wow.
Minutes.
Time sure flies when you're having fun.
I know,
does.
right?
Yeah. We'll have to do this more often.
So
You better be here more often then.
You know, it's not my fault.
scheduling conflicts. He's a popular feller.
He is.
No. They just say, we've put up with you enough. It's time for you to go on the road.
So hey guys, get your phones.
Update the app.
Double check. If you had your phone on auto update, there are still instances, and I had that instance where it didn't auto update. I actually had to go back into the, I'm on an iPhone, so I went back into the App Store, but it's the same thing on the Google Play Store. you go back in and look up the app, and then it'll show you that it's got an update available and updated. If you don't see the 4 buttons at the bottom of the blue on screen, that means your system hasn't updated yet. So
Go into the forum, ask your questions, help other techs out, post some memes, have a good time. It's fun. Go check it out. It's awesome.
It's time for a lot of you to start giving back and make some comments on some of these things on the forum, because you may explain something or say something in a little different way than I say it that will strike a chord with somebody, and they'll say, wow, I got it.
Brian, what are you doing?
hey guys, that's
Oh man.
gotcha. Gotcha.
Anyway, next buckle up is September 2nd.
She said she wouldn't get in front of the camera. Guess what we just did?
We cheated.
Put her in front of the camera. September 2nd, 4 o'clock Pacific.
We'll do a rookie mistakes one time
We're going to get her on rookie
when Mike
mistakes.
isn't here.
Yeah.
We'll do rookie mistakes.
We're going to do it. It's going to be fun. Again, guys, send in your comments, send in your notes. Tell us what topics you would like us to cover on Buckle Up with Mike.
And Brian.
And I'm not Brian. Or I'm not Mike. That's Mike. I'm not Mike. I screwed that one up.
You did. But no, I mean,
Peace, guys.
these are for you guys. So whatever is going to help you, let us know.
Yep.
Woo! Tell your friends. Download the app. Best app ever.
Yeah.
Peace.
Peace.